Good evening. Let's check the audio and we'll start a webinar. Let's check the audio and we'll start a webinar. Yes, okay, it's fine. So today we are going to see about how big data is working. Okay, so big data webinar on big data. So this program is conducted by JBAS College for Women, Thenambed. So on this the Department of Computer Science Engineering is conducting this wonderful webinar on big data association with Pantech eLearning, and today we are discuss about what is big data and why we are using big data and what is the purpose of big data. So if you want to do any big data process, means what type of software in existing we have, and in now currently what type of software we are using, and what are the things in big data is important, and what are the domains playing the major role, we are going to see in this today's webinar on big data. Okay, so let me enter into the session, how it's going, how it's big data working, and we will see one by one. Okay, so again I am telling this program is conducted by JBAS College for Women and the Department of Computer Science Engineering. I like to give special thanks to HOD of the respected department and principal of the respected college, and then coordinator and faculties of Department of Computer Science Engineering to conducting this wonderful webinar on big data. Okay, so before we are going to the webinar session, this our Pantech solution, our main profile is origin from 2004, and then 7 branches, 100 plus employees, and then 1200 plus workshops we are conducted on each and every domain. Okay, so not only in particular domain, we are covering each and every domains like power system, power electronics, and then renewable energy, and and then machine learning, deep learning. Okay, so like this we are covering most of the workshops, different type of domains for students, and then our main portfolio is like research and development for industries projects, and then faculty development programs, and then hands-on training for workshops, internships and in-plant training, and then short-term course, value-added course, academic projects training, and then customized design services and states. So these are the main portfolio. And we are also covering EC and EEE domains like Internet of Things, IoT, artificial intelligence, embedded system, VLSI, FPGA and TMS processors, and then image processing with OpenCV, network simulation, power electronics, and electric vehicles. So we are covering even academic projects for college students, so EC and EEE domains, and we have CSE and IT domains also. It's fully related to software department like big data, data analytics, Internet of Things, Python and Android Kotlin, Android application development, data, image and text mining, cloud computing, mobile computing, and then we have machine learning, deep learning, like this. Okay, so the table of contents. So in this webinar today we are going to see about what are the things we are going to see about, like big data introductions and problems of big data, and then Apache Spark. What is Apache Spark and what is the use of Apache Spark, and then introduction to Spark and applications and libraries of the Spark, and then data science, PySpark application and partition, how to set up and run the Apache Spark. So these are the area we are covering in today's webinar, like table of contents. You can see, like this is the things we are going to see about in this webinar. If you see the webinar at the till end of this session, you definitely learn about what is big data and what is the use of big data, and most of the things you can see softwares and what are the things we are using for big data softwares. Okay, so introduction to big data problems. So introduction to big data problems. So first of all, when we enter into the session also, we need to know what is big data, right? In name itself we have a suggest exactly what is big data, but it's we know actually defaultly we know about exactly big data. It means we have a large amount of data, we need to compute those data for our research purpose, for any information gaining. Otherwise you will use some other like company wise, or you need to gain some information in those data, means you need to use big data. Okay, so big data have mainly where we can use. Okay, so what is big data means? It's nothing but it's have a TB amount of terabyte, that is terabyte or petabyte or exabyte. We have large amount of data, right? Then why we are using big data means we can use big data for web applications, social sites. Social sites means like Facebook or Twitter or Instagram. Okay, and structured and unstructured. So if you take big data means definitely we have structured and unstructured type of data, and then analytics. So main purpose is using big data, we are doing an analytics. So analytics is the important things nowadays. Okay, so if you are do any recommendation system based upon your interest also, we need this process, analytic process. So that is important. And then how we are using big data means like storing, processing using Hadoop or Spark. Okay, so Hadoop is separate one and Spark is separate one. We will see definitely what is Hadoop and what is Spark, what is the use of these two, and then which one is better one, we will see in this webinar at the last. Okay, so don't quit this video, because you will learn definitely what is big data and what is the use of big data. It will be useful for you for your future purpose. Okay, so this is the thing we are going to cover in big data. And big data characteristics. Big data characteristics, we have totally 3 volumes. Like we have volume, velocity, and then variety. Volume, velocity, and variety. So volume is nothing but like sizes and amount and quantity of the data. Okay, so how much we have data. Then velocity. So velocity means if you are moving data, your data from one place to another place, otherwise from your local disk to any other local disk, how much speed it's moving. Okay, so just simply I am telling an example, but velocity example, but in big data wise it may change. Okay, so like that. And then variety is nothing but type of data to be stored or processed. Okay, so what type of data we are storing if it is a structured data or unstructured data. If it is structured means we need to do different type of process. If it is an unstructured type of data means we need to do some different type of process. So we need to do that one. So this is important if you are taking a big data. And let me enter into the big data problems. So what are the problems? Here you can see power of computer application and hardware grow within the time. Okay, what are the basic problem about big data means each and every day we are getting an each and every day we are developing a new application and new application changes and new hardware changes also. Okay, so sometimes we are getting 4 nano technology processors and next day we are getting 6 nanotechnology process. Like that, processors, nanotechnology of the processors and hardwares will be changed, and then applications, uses of applications also will be changed. So this is the major problem. Okay, so we are, if you wanna working with big data problems, okay. So each year we have a new processor, and then to perform the operation faster, and then application to the run the top of the automatically got faster. Okay, so this is the vast problem. So for overcome this problem we need to achieve some advanced technique which will handle the large amount of data within few times and we will get an output. Okay, so how means using some processors like using some softwares like Apache Spark or Hadoop. Okay, so here you can see if you have a much data available to the way of processor to analyze that processor, it will be changed radically. Okay, so it will be computation wise also it will be, we need more computational power of that laptops or any other computers. Okay, so if you are doing any problem with your big data means we need some advanced technique of computers, like they will call us a supercomputers. Okay, so using supercomputers we can compute easily. Okay, and here we are entering into the Apache Spark. What is Apache Spark and what is the use of Apache Spark? Okay, so why we are using Apache Spark? First of all, before we go into that queries, what is Apache Spark? So Apache Spark is one of the computational engine. Okay, Apache Spark is one of the computing engine. Okay, so it will be give like libraries of parallel data processing clusters of computers. That is, it's a nothing but it's a computation engine. It will be parallelly we can process the data from different type of computers. Okay, so the combination of computers we will do some process of big data analytics means definitely we will get an output within few minutes or few hours. Okay, so that is the use of Apache Spark. So it's nothing but it's just a software. We are using that software, we are connecting the cluster of computers locally and then we are computing our big data problems. Okay, so this is the uses of this one. Then Spark. So Spark is a big data solution that can be proven to be an easier than the Hadoop MapReduce. Okay, so in existing we have a Hadoop MapReduce. So in Hadoop MapReduce we are using in existing, that is in olden days. Now we are using Apache Spark. Okay, so don't worry, definitely we will see about what is Hadoop and what is Spark. Okay, so let me see next slide. So here we have a comparison why we are using an Apache Spark, what is the difference between old one and what is the computation speed of Apache Spark. So comparing to the old one, that is Hadoop, we are generally cluster like improving the efficiency. Okay, so here you can see we have a memory data sharing and then general computation graphs, so up to 100 into faster, that is compared to that one. Okay, so compared to previous one the computational speed of the Apache Spark is higher, okay, that is into 10 times faster than the 100 times faster than the previous one, okay. Then we have a usability, improve usability through like 2 or 5 less than code, okay. So what is the, here we have rich APIs like Java or Scala or Python. Using that we can achieve the less code, okay. So we don't need to write an n number of lines, we can write just 2 or minimum amount of lines, and then we can do it, okay. So this is the Apache Spark. And then we have Spark SQL structure and Spark streaming real-time M library files, and then GraphX, okay. So these are the some of the applications we can use our systems, okay, like Spark SQL structure query language structure. So you can use this type of domains. And then we have Spark streaming real times, and then ML library, and then GraphX, okay. So this is the one of the basic domains we are using for our big data, okay. So here we have a ecosystem, like storage, management, and then engine, library, and programming, okay. So what is the storage? First of all, so storage wise, we can, if you want to go, means we have a local FS and HDFS and Amazon S3, and then RDBMS, that is relational database management system, and then NoSQL. So without SQL we can take storage. So storage is not a problem here, right? And we can save as a DBMS style, or we can save as a HDFS. So it's in any format. But management here you can see Yarn, okay. Yarn is one of the management, and then SOS, and then Spark. So this is the management, that is if you are collecting some large amount of data, okay. So we need to using those data we need to achieve some task, achieve some output, means we need to manage those data at the time, during running time we need to manage. So for that purpose we can use Yarn or MESOS or Spark, okay. And then we have engine Spark Core. So Spark Core is the it's a general unique engine for all the management and storage. And then we have a libraries. So libraries are important because using that data, which way you are doing, you are processing. For example, if you are processing using machine learning way, we need machine learning type of library package. If you are using just for data analytics, we need to use GraphX, like that type of things, okay. If you are using for streaming type, you can use Spark streaming, okay. So like this, what type of using those data, what you need to do, okay. So exactly we need to choose according to that, we need to choose our library package. And then programming language. So programming language, we have different type of languages like Scala or Java or Python or R programming language. So using this we can develop and thinking, okay. So that is the use of programming language. And then we have, this is the comparison between Spark and then other HDFS, Storm, MapReducing and all, okay. So before past year, and the codes, lines of code changed, okay. So this is the way we have. And then introduction to Spark, okay. So what is Spark and what is the use of Spark, we will do. So I already discussed you, we have previously we have map reducing technique, right? So we will see about what is first of all map reduce. It's a, when you know existing means, definitely what is the difference between existing and proposed, definitely we will get into the point. So we will see what is map reducing in next slide. And then here new programming model will be achieved like more complex. so that is for ML graphs and all, and then it's a more interactive, and then it's a real time. So this is the 3 need faster data sharing parallel apps. Okay, so now let me see about the old data sharing using MapReducing. Okay, so MapReducing we already we will discuss now. Okay, what is MapReducing? Here you can see welcome to Hadoop. So here I am having an input data, welcome to Hadoop, class Hadoop is good, Hadoop is bad. Okay, so we have totally 3 line. We have totally 3 line. So in this 3 line, we need to do map reducing technique. Means first of all, what it will be happen means, if you are giving any input, we need to split into an 4 type. Okay, so that is we need to split into the 4 type. One is welcome to Hadoop, that is first line, welcome to Hadoop, and then next line class Hadoop is, and then next line good Hadoop is, and then bad. That is, if you are giving any input, first the map reducing technique will be do input splits. Okay, after splitting this data into the input splits, then we will go into the mapping techniques. Okay, the mapping techniques is nothing but it will be count the each words. Okay, it will be count each words in input splits. Okay, what is the words? For example, if you take a first one, welcome to Hadoop. So welcome will be a one time repeating, and to one time repeating, and Hadoop one time repeating. Then next one has class Hadoop is. So like that it will be how many times the word is repeating. It will be splitted into one like this. Okay, so this is mapping. Okay, so input split to mapping like this only. After mapping, it will be shuffle the mapping words. So how it's shuffling means based upon the repeated words. For example, here we can see bad is only one time repeated in my input, so it will be one time. Then class one time, then good one time, but Hadoop will be repeated for 3 times in my mapping. Okay, so it will be arranged to here. So what are the repeated words in our mapping technique? So it will be automatically shuffling into the separate one. Then based upon that shuffling data, we will reduce our input data. So how we can reduce means using the counting values. So here you can see Hadoop is repeating for 3 times. So I reduced it into an only one time with count value 3. So if I delete one Hadoop in my shuffling or in my input data means automatically here Hadoop comma 2 will be come. Okay, so that is the use of shuffling and reducer. So now after I am doing this reducer, I am getting a final output only this much only. So compared to previous input, we got a output only like a few words. Using these few words itself, we can do some process in big data analytics. So this is the process of map reducing technique. Okay, so but if you taken with data sharing in RDD, okay, so if you are taking a data sharing in RDD, it's a different way. So for example, if you have a list, so list is nothing but it's a mutable, and it have a number 1 to 99, so it's a mutable one. So here we have a list, mutable list. So we are just splitting our list into an like randomly from 1 to 17 and 18 to 25, like that we are splitting the RDD, and then we are saving it in first physical memory. Okay, that is physical memory, generally they called as workers. Okay, we have totally workers and then masters. So first we will share it in physical memory about all the lists. After we will share it in physical memory, we will give it to the masters node. Okay, so this is the data sharing in RDD. So if we are doing like this, we can increase our network size, that is 10 to 100 times faster of the network and disks, okay, compared to the previous technique. So this is the thing we will see. Input one time processing unit, so we can achieve the queries, different type of queries, and we can get a result. So this is the use of this technique. Then Spark model. So Spark model in Spark model we are using RDD techniques only. So we are seeing now only this one about RDD techniques. So we are using that technique for Spark model. Okay. So what is the use of RDD technique means? We cannot say where the data files need to save. So it's randomly saved from the worker data anywhere, and then automatically it will be given to the master node. Okay. So this is the Spark model. So already collection of objects that can be stored in memory disk like this. Okay. So here log mining. Now we will see one real-time example how we can apply the Spark. For example, log mining. So log mining is nothing but we have data, some log data. Okay, log data means we have some data, but it's not in a structured form, it's in a log data. So what we have to do means we need to first convert those unstructured data into a structured data. Okay, so for that purpose I am doing some processing like cleaning of data, like we will check whether we have a null values or not, or whether we have unwanted columns or rows we have, like that we need to check something. Okay, so like using that cleaning of data, if you have null values means you need to remove those null values. After removing that null values we are converting into a structured form. Okay, so basically if you take any log data, it will be not in structured form. So what is the difference between structured and unstructured data means? If you take an structured data, you will be have like rows and columns exactly like if you take an report of hospital's patient, we have exactly details about age and then gender and then what is the reason he joined, like that we have some exactly details, okay, about the patient. But if you take an unstructured data, like we have different type of topics we have, like if you take unstructured data like HTML files, for example you can take HTML file. So if you need some data from HTML file means we have those data, but in between we have some tags like p tags or some other header tags, okay, like that we will have some tags. Okay, based upon the tags we will collect the data. So we need to do some process to collect the particular data. Okay, so that is unstructured data. So here I am using an unstructured data. Using that unstructured data I am cleaning some unwanted data and I am retrieving into the structured data. Then after that I am analyzing the data. So analyzing the data is nothing but, for example, if we have a data of like customers, for example we can take it as a one normal soap company. Okay, so we have, for example we have a soap company, ABC soap company. So ABC soap company will be upload the data each and every day how much they are selling. Okay, for example Sunday 10 soaps are sold, and then 15 days Tuesdays we are sold for 20 soaps, and then Saturday we sell like more than 15 soaps. Okay, so based upon the data we will analyze those data and we will look for which day it's sold higher amount of soaps. Okay, for example Saturday will be sold for higher amount of soap means the ABC company will be concentrate on Saturday by giving some offers, extra offers. So if you are buying an 2 soap means we will offer you 3 soaps, like that we will concentrate on, like that. So that is analyzing of data. So unleashing of data after we are getting to the result, that is which day we need to sell. So that is the log analysis. Okay. So here if we are doing those process, during those process, if you are, because we are not doing with small MB like 100 MB or 200 MB of data, we are processing those data with terabyte or more than TB. So we are doing those processes. So at that time, if you are getting any fault, okay, if you are getting any fault means automatically the RDD systems will be collect those fault details and then try to rectify those problems, rectify those errors. Okay, so that is one of the important of RDD data. Okay, RDD things. Okay, so here if for example if you are transferring from one system to another system some data means some anything fault will be occur, automatically it will be taken from the metadata and then it will be rectify the fault tolerance. So that is the use of fault tolerance. So here you can see I am taking a machine learning algorithm. The algorithm is logistic regression algorithm. So logistic regression algorithm, here I am using some any anonymous data. Okay, so anonymous data, then I am looking for both Hadoop and Spark accuracy result. Okay, so how it's working for logistic regression. So here y-axis will be a running time and x-axis will be a number of iterations. For example, in x-axis first iteration I am blue color is Hadoop and then orange color is Spark. So blue color, that is its Hadoop will be performing very well compared to Spark for first iteration, that is running time. Okay, not a very well, Hadoop will be a run higher amount of time, takes some higher amount of time compared to Spark. At fifth iteration even Hadoop will be take minimum 1000 running time, near to the 8000 or 6000 running time compared to Spark. So if we are increasing the number of iterations also, the Hadoop will be taking some time to give the output result, but Spark will be taking same time from starting to ending number of iterations. Okay, so that is the basic comparison of logistic regression algorithm. It's a machine learning algorithm for supervised learning. Here we are getting like this. Okay, so that is the performance. Like here you can see the time started by 100 TB. Here at 2013 record for 100 TB we need 2100 machines for, that is cluster of machines. So generally what is big data processing, we need some cluster of machines. Using those machines we need to process the big data, right? So we are using at 2013 2100 machines. Okay, at 2013 we are using 2100 machines to working those minimum 100 TB of data. Okay, it takes 72 minutes. But if you are using Apache Spark in 2014, we are using only 207 computers machines. Okay, and it will be take only 23 minutes for this same data processing by Apache Spark. Okay, so that is the use, that is the major improvement compared to previous existing and proposed. Okay, so that's why I told you Apache Spark is one of the important techniques nowadays we are using for big data analytics. Okay, and then here we have operands. Support operators like map and then filter and then group by union. So operators is important, right? So whatever programming language operators is important, because based upon the operators only we will work with some important data like appending or like reducing, or we will counting or reducing by key base, like that we will use some operators. So here we are using some of the important operators. The pipeline, here we can see we have a pipeline. We will discuss about this, what is pipeline. Definitely it will be useful for even big data or normal machine learning or deep learning technique also. Okay, so we will see about what is pipeline. And then here we have a user community, okay, because who are all using this Apache Spark. Okay, so user community, we have more than 500 productions users, and then cluster of 8,000 nodes processing with 1 PB per day. Okay, not a TB, 1 PB per day using 8,000 nodes. Okay, so single job over 1 PB. Here you can see Yahoo, eBay, Netflix, Amazon Web Service. Okay, I need to tell you about one thing. So compared to this all, except Amazon, compared to this all big data community, okay, so Amazon will be an most of the share in big data. Okay, so Amazon will be a most of the share compared to this all community. Okay, so it's Amazon is a big web service applications you can use compared to this all. Okay, Netflix or Cisco or data stacks or data bricks. Okay, like that. User community, and then applications and libraries. Okay, so what are the applications? First of all, because we seen about how we will use, what is the use of that one, like that and all, but it supports programming language Python, Scala. This also we seen in ecosystem, right? What is the ecosystem of Apache Spark? We seen already, like SQL task and data streaming and single machine or cluster of computers. This and all we seen, right? Next one, libraries. So these are the important libraries like SQL plus data frames. So here most of the person will be know about SQL, the structured query language. So if you need to do some process with the data means we will use structured query language. But one thing, what is data frame? Here most of the persons will know or may not be know, but I will tell you what is the data frames. Data frame is nothing but what is frame? First of all, frame is nothing but we it's a square shape or triangle, like frame. Okay, normal photo frame like that na. So frame with data. So frame with data means we have n number of rows and columns with one frame. Okay, so this is data frame. So if you have a rows and columns in your data, that is called data frames. So if using this data frame, if you need to take particularly this column or particularly second column means you need to use SQL queries to take those data. That is the use of Spark SQL plus data frames. And we have streaming, for streaming purpose we can use, and then we have ML libraries, machine learning libraries, and then we have GraphX for analyzing, data analyzing. So like this we will use different type of areas. Okay, and we have Spark Core API also, like R, SQL, Python, this and all. Okay, so here we can see Spark SQL data on this one. Okay, so Spark streaming purpose. So streaming purpose we are using mostly RDD. If you want to stream, you can, we will definitely use based upon the RDD type only. We will stream the data, any data. Okay, for ML library. So if you want to import an k-means algorithm, you can directly import k-means using some important library package, and then we will import the k-means and train the k-means. Okay, so here I am training the k-means using training function. I am training the k-means, and then I will get a trained k-means model. Then I will give the new point to predict an output, whether it's 0 or 1, or whether it's true or false. Like that I will predict the output. That is the use of ML library. Okay, so GraphX, basically I already discussed about ABC structure of game, right? So that is the use of this one, user data and product data, and then we have like this. Okay, so this is the uses of GraphX. Okay, then next one we have performance and specialized engines. Okay, what is the performance and specialized engines means? Like we will actually till now we seen about SQL streaming and ML libraries. Okay, so SQL streaming and ML libraries, what is the performance and what is the specialized, we are checking here. Okay, so here you can see here first one for SQL we have a response time as a y-axis and x-axis as a SQL. Here for Spark we are getting this much response time compared to any other thing, and for streaming purpose throughput time, that is streaming means we need MBs, megabytes, transferring the megabytes from source node to destination node, right? So for streaming purpose the throughput compared to Storm, so the previously we are using Storm, now we are using a Spark. Here more than 25 megabytes we are streaming for each seconds. Okay, for machine learning we are like response time, so previously we are used MAH out and then graph lab, now we are using Spark, so we are getting less than 10 minutes. Okay, so that is the use of performance and specialized engine. And then combining processing type, so combining processing type is nothing but if you have different type of function. Okay, for example here you can see I am having a data, the data will be stored in a variable name points, and then machine learning model will be stored in a variable name model. So I have two variable, one is point, another one is model. So we can using this model you can combining the process type. For example here you can see I am using the lambda function. Okay, lambda is nothing but we can write the function within single line. Okay, using single line we can write the function. Okay, so using lambda function I am combining the model and then location, everything. Okay, so that is the use of this one, points and model, combining process type. Okay, then next one here you can see combining process types in basically here you can see we have separate engine only previously, but we have separate engine previously and we are combining those separate engine into a single engine. Okay, so here we have prepare separate engine, train separate engine and apply separate engine, but we are attaching all the engine with single one. So that is the use of Spark. We can achieve this using Python programming language or Scala programming language or using HDF. Next one, data science. Okay, so data science is important if you are taking machine learning or deep learning or big data. So data science part is somewhat important. Why? Because we need to manipulate some data from one place to another place, or we need to delete some data, or we need to drop some data. So for that purpose we need those data science part, right? So first we will see about data science, and then next one we will see about platform interface of data science. Okay, so data science we already know, we can use data science using R, that is R programming language, or Python library packages. Using that we can check it out. Okay, so here we already discussed about data frame. Google only trends the data frame types from 2007 to 2015. Why? Because mostly the data frame types are not used by most of the person before 2006 or 2005, but Google only trends the data frame type. Why? Because it's easy to modify and easy to collect some particular data compared to normal SQL like that. Okay, the Spark data frames. So here we have a Spark data frame. So compared to normal things, here you can see automatically optimized by Spark SQL. Okay, so machine learning pipeline. So we need to discuss, this is the important technique nowadays. We already know about the Python language. Okay, so it's a high level programming language and we can if you are writing any code, it will be easy and minimize n number of lines, right? But if you are using a pipeline, okay, if you are using a pipeline technique, we can even more reduce the processing technique. How means, for example, here you can see, if you want to train one model, if you want to train one data frame model, we need to do tokenizing. Tokenizing is nothing but if you have a continuous string value, converting that string value into a single words, that is called tokenizing. Okay, after tokenizing, I am using TF. TF is nothing but it will be convert your single words into an, that is we see in the map reducing technique, right? So we have a separate words, and then those words will be count the words according to the repeating times. So 0, 1 or 2, 3 like that, it will be count the words using TF vectorizer. Okay, so it's generally called vectorizer. In machine learning we have vectorizer like hashing vectorizer and TF-ID vectorizer and then count vectorizer. Okay, count, COUNT, count vectorizer. But here we are using only an hash vectorizer. Here you can see hashing vectorizer. And then after I am using logistic regression algorithm and I am training the model. Okay, so here I am training the model. So when I need to train one model means for one data frame, text type of data frame, we need to do this process. First one tokenizing process, and second one hashing process, and third one training the model. So we need to do totally 3 steps. Okay, so we need to achieve these 3 steps. If you take generally in machine learning means we need to do these steps separately, and we will test the model. But if you use pipeline technique, if you are using a pipeline technique, we can directly implement those 3 model into the single line, and then we can directly train the model. Okay, so that is the use of pipeline technique. Okay, so we can combining these 3 technique into a single line, and then we can achieve the training the model. So that is the use of machine learning pipeline. Next one, here you can see Spark R interface. So how we can interface with R using JSON file, this one, and then we have platform interface. So we seen about data science, and next we will see about platform interface. So platform interface means we have different type of platform to interface, like Cassandra or Apache, or Hive, or Parquet, or PostgreSQL, or JSON, or MySQL, or Elasticsearch. So these are the some of the framework, okay, used for API framework. We can using those framework we can connect with Spark, and after we connecting with the Spark, for example, if you are connecting with MySQL with Spark means you can select like this, select from MySQL user for join Hive logs, like that we need to use. Okay, so this is the source API. Okay, so it will be allow the plugin of smart things, and then it will process the logic into the source code, and then we can retrieve the data. And then current data source, so generally what are the current data available in our data online, like CSV file, comma separator value, and Elasticsearch, Redshift, like that we have different type of DB database we have. And if you want to learn about Apache Spark, you can use the website, the Spark apaches.organization. Otherwise, if you want to try the Apache Spark, you can use Databricks Cloud. Okay, they will give Databricks Cloud. They will give the cloud. Using that cloud, you can connect different type of software, and you can try the Apache Spark. If you want to try, if you want to download the Apache Spark, you need to go to this website. Or if you want to Spark Summit means you can use this one. Okay. So how we can install our Apache Spark, and what is the partition, we can check it out. Okay, so if you are installing an Apache Spark, we got totally 3 partition. Okay, so we got totally 3 partition. One is driver process partition, and then we have a executor partition, and then we have a cluster manager partitions. Okay, so we have totally 3 partitions. Okay, so let me see one by one what are the partitions, like driver process partitions, what is the use, and executor partition, what is the use, and cluster manager partition, what is the use. Okay, so if you take a driver process partition uses mean we have 3 main tasks for driver process uses. Okay, one is hold the information. Hold the information means generally all the information available in this driver process unit only hold the information and respond to the input. Okay, so if you are giving any input, otherwise if you are giving any task, based on the task you need to respond the input, respond the task. Okay, then if you need to do analysis or distribute any streams, you need to do this one, driver part. Okay, then executor part. So executor part is mainly what the users means. In name itself we have a suggest, the user will be assigned some task, those tasks will be executed by executor processing partition only. Okay, so according to the execution it will be move on to cluster manager. Okay, so cluster manager is nothing but it's a physical computer only. So how, if you are giving n number of tasks means it will be splitted the task into a different type of physical computers, and then the physical computers will be train the task, and then we can achieve the output within the cluster manager. Okay, so how we can set up the Apache Spark, now we can see. So we can set up the Apache Spark. If you want to try the Apache Spark, first of all you need to go to this website databricks.com and try Databricks. Okay, so first of all you need to go to website. If you want to install, you can use the official website of Apache Spark and you can install it, but you just need to try your Apache Spark application means you can use databricks.com. They will provide the cloud. Using that cloud you can build the simple Apache Spark with n number of, we can achieve even cluster also. Okay, not only for one single node, we can combine the cluster of nodes using this try Databricks website. Okay, so here you can see if you are entering into the Databricks, you need to, it will be asked if you want to use Databricks platform for free trial or for community edition. Okay, so you can click the community edition. Okay, so after you can check it out free trial, because in community edition only we can cluster 3 maximum user, we can cluster, like maximum we will cluster of 3 users. Okay, so 3 user you can cluster it. So first of all you can just get started. After community edition, here we have a new notebook. If you want to create a new notebook, you can create it, or if you have a data from your own, you can drop your data, or you need to create a new notebook means you can create it. So using this new notebook you can create, and then here you have an option of cluster. Okay, so you can create minimum 3 cluster, and then we can achieve the big data that is we can achieve the Spark, Apache Spark. Parallelly we can work with 3 different type of cluster computers, and we can compute an input and output. Okay, so that is the line of so some of the machine learning with Spark, that is some of the basic operation with Spark is like data pre-processing and data processing with pipeline, and classifiers and training and testing, and then evaluation of the model. Okay, so these are some of the basic technique for machine learning. Okay, so for streaming purpose, for graphics purpose and all, they have some different techniques, but just I am showing you what are the basic steps for machine learning with Spark. Okay, so this is what I need to tell you about big data. Okay, so I hope everybody will understood about how big data working and which is the software we are using nowadays for big data. And if you have any doubt, or if you have anything queries about this webinar, you may ask it in our comment section. I will reply you for 2 or 3 minutes. So if you are new to this channel, please subscribe the channel and hit a bell icon. Definitely you will be get an idea about different type of domains. So the registration link, attendance links will be given to registration attendance link will be pinned on description and then in chat box. You just check it out. Do you have any doubt? You can ask. We will discuss about real time, how it's working and all. Okay, so most of the persons don't have doubt, I think so. So before that, I need to tell you one thing about we are conducting an technical training program with IETE, that is Institute of Electronics and Telecommunication Engineering, and you will be get a certificate with IETE logo. It will be start from 3rd August onwards. So till it's going on 5 days internship program. Technical training program. So if you want to join, you can join. It's 2 hours per day. Fee structure is 300 for ISF members and 350 for non-ISF members. And we are conducting the Pantech IETE internship program. Okay, so it's an internship program, that is training program. Generally it's been 15 days, 3 weeks. So each day we are covering some different topics about particular domain. The fee structure for this program is 1600 because it's 15 days. Each day is per student. Okay, so if you are IET members means, if you are non-IET members means 1750 per student. Okay, so if you want to register for this to any one of the internship, you can contact this number, Mr. Sindhil Kumar, Mr. Srinivasan and Mr. Kumarasamy. They will help you for registering the training program, technical training program or internship, 15 days internship, or if you need webinar like this for your college also, you can approach this, they will help you. Okay, so thank you for this wonderful webinar by Big Data. Okay, I hope most of the persons will be understood about this, how it's working big data and what are the uses of big data. Okay, so if you need any other even more details about upcoming events or furthermore information means, you may contact on WhatsApp number 7010888841. Okay, so if you need to contact Telegram also, you can contact available. And thanks for the respected college, JBAS College for Women, Tenambet, and thanks for the respected department also, Department of Computer Science in Engineering. Okay, so conducting this wonderful webinar, association with Pantech eLearning. So that's it guys, thank you all. We will see it on next session. Up till it's signing off from Kamlesh. Thank you all.